Okay, picking back up with more on integrals worksheet 2. What we'd like to do, I'm just going to do a little bit of erasing just so we don't have to move a lot about. What I'd really like for us to be able to do is to get this thing graphed and to be able to get particular points. Now we've got information on that top right part of the screen, and it's all great. It's wonderful. Remember that we're asked to graph G, and what was G? G, you could see, is this thing right here. It's going to be the integral from 0 to x of f of t dt. And no doubt about it, you have some information already. You know what's happening at -1 on G. That's good. That's wonderful. Really, I'd like for us to go through and find out what's happening at -2, at 0, at 1, and at 2 as well. We can do this because this is really just some area calculations. So, for example, if we were to say g of -2, we're going to integrate from 0 to -2 of f of t dt. And this is going to equal, then, the negative from -2 to 0. And as we look at this, as we're going to investigate that, you could say, well, what's going on from -2 to 0? Well, from -2 to 0, I hope you can see very easily that you're going to get this triangle here and this triangle here, one of them above the x-axis, one of them below. And of course, we could figure out what the area of those triangles were. We figured out from part A that it was 3/2, 1/2 base times height. The height was 3 and the base was 1. But look, one's positive, one's negative. So what are we getting at? I hope you can see very quickly that these are going to wipe out to 0 very nicely and quickly. We already saw that g of -1 was actually going to equal -3/2. You can think, where did we get that? Well, from right here. What about g of 0? Hey, that's about as nice as you could ever ask. It's integrating from 0 to 0. Because again, I hope it's crystal clear what's going on. When I say g of 0, I've got to put a 0 inside of x there, for inside of g, but also in that upper bound. My goodness, if I'm integrating from 0 to 0, I get a 0. Look at that. How about g of 1? Well, that's integrating from 0 to 1 of f of t dt. And at that point, if you were working that out, I hope you could see pretty fast that that's going to be right in here, from 0 to 1. Don't have to flip any bounds, best of all. Well, here's your base of 1, your height of 3. Like we said, 1/2 base times height, that's going to be 3/2, and a positive 3/2 at that. How about when we integrate up to 2? Well, we're going to say 0 to 2 of f of t dt. Well, now you're just going to have another triangle right over here. You've got from 0 to 1, we just did that. But as we extend out to 2, you're going to see you have a congruent triangle, but this one goes under. So you have a positive 3/2 and a negative 3/2. That's going to wipe out to 0. Wow. So at this point, I want to make a real quick graph of G. Look at this. Here's G, and you can look at your y values. It looks like we're going, all the way up to 3/2, which is 1.5, right? So, -1/2 over here, and looks like we'll have -1, -2. Let's just begin to put this all together. At -2, we're at 0. for our g function, right? At -1, well, that was from part A. From part A, we're going to be down at -3/2, -1.5. What about at 0? Well, at 0, at x equals 0, we're at 0. How about at x equals 1? Well, at 1, we're going to be at 3/2, or 1.5. Then how about at 2? Well, at x equals 2, we're back at 0. But does this make sense with our number line? It says that we should be decreasing from -2 to -1, and then we start increasing. Sure looks like it. We also know we have concavity. This would be concave up like a cup. And then what? We're going to keep going up. But at x equals 0, everything changes to concave down. Concave down like a frown. So I keep going up until I get up to x equals 1. Then I bring it back down. So look at that. You could figure out the specific y values on g very quickly. You could pull together a first derivative test here, a first derivative analysis to see where you've got extrema. By the way, plotting the points would kind of let you know that. Looking at the second derivative, you can then know curvature.